Hello, fifth graders. Ms. Jagodnik here. I'm coming with to you with our last lesson in topic 16 on geometry. This is lesson 16.4, and it's all about constructing arguments. So reasoning through different questions or thoughts about all the geometric shapes that we've learned about over the last few days. So I'm going to go over the problems that were independent practice on pages 871 and 872. I hope you've tried them already. And now you can go along with my arguments, see if you were thinking the same thing. Maybe you explained it a different way, and make sure that your thinking was on point with all the geometric vocabulary and concepts that we've learned here. So starting on page 871, these are questions 4 through 7, but they're all about this one basic idea, Lauren's argument. Lauren says that if I draw a diagonal in a trapezoid, neither of the triangles formed will have a right angle. And we want to know if she's correct. So first we have to think about exactly what she's saying. We're talking about the shape trapezoid. We know that means it has one pair of parallel sides. And she wants to draw a diagonal through it. So from one corner to the opposite corner, not vertical, not horizontal, diagonal. And she says that she's going to get two shapes. They're going to be two triangles, and neither one of them will have a right angle. So the easiest way to do this is to make a drawing and to sketch it out. So let me draw my trapezoid. Okay. Here's an example of my trapezoid, and I want to draw a diagonal. So from one corner to the other. Okay. She does have two shapes. She does have two triangles. Do they have a right angle? No. This is an obtuse triangle, and this, okay, seems like is maybe an acute triangle. It does not look like they have a right angle because this was not a right angle and it's not being cut up equally. So I'm going to say for this trapezoid, she's right. But now I have to think to myself, is that the only kind of trapezoid there is? And I know it's not. I know there's also another kind of trapezoid called a right trapezoid that looks like this. So instead of a slanty line, it has a slanty line on one side, but the other side is straight up and down. And it's called a right trapezoid because these are right angles. So now what if I divide this one with a diagonal line? If I do that, boom, then again, I have two triangles. Okay, this one is an acute triangle, looks like. Oh, but this one has a right angle. So with this kind of trapezoid, she is not correct. So my overall answer is going to have to be no, not always. Okay. Sometimes that is true, but sometimes it isn't. It depends on what kind of trapezoid you have. So if we want to go through the actual answers of the book, number 4 asked you, what is the definition of a trapezoid? So we already talked about that. It's got one pair of parallel sides. Okay. Number 5 asked you to draw examples of a diagonal in a trapezoid. We did do that to solve the problem. Number 6 asked, how can a drawing help? Okay, because this is an example of her being correct, but this is a counterexample. It's an example that shows that her statement is not correct. So drawings can help us either prove something is right or give a counterexample and prove it's not right. And then number 7 finally asks, is Lauren correct? And the answer is no, not always. If you have a trapezoid with no right angles, then she might be correct. But if you have what we call a right trapezoid, then one of the triangles I create when I divide it up is going to be a right triangle because that right angle is going to be there untouched. Even if I put my diagonal in the other direction, then this right angle would be part of one of the triangles. So that is my answer for the problem on page 871. Okay. Now moving on to 872. 872 is a fun problem here that deals with a whole bunch of different flags. So we have 4 groups of kids that have drawn different flags, and if you look at the flags carefully, you can see that they have a bunch of different quadrilaterals on them. Though if you look in your book, you can probably see a little better just because you can see it a little closer. Now, they're asking me a few different questions based on these flags. Number 8, which flags show parallelograms? So I need to think back about what a parallelogram is, and it sounds just like its name. A parallelogram has all sides that are parallel. So the top and the bottom are parallel, and the two sides are parallel. So which ones are parallelograms? This one definitely looks like it is. The two sides are parallel. This is what we usually call a parallelogram because there's no more specific name for it. This looks like a rectangle, and we know a rectangle is a kind of parallelogram because the top and bottom are parallel and so are the sides. So I'm going to go ahead and say that the red flag has parallelograms. But I notice it says flags, so there might be more than one. Let's check the others. Nope, this one is a trapezoid, definitely not a parallelogram. Oh, what about this one? This one has rhombuses. Or I like the other way. There's two ways to say that. More than one rhombus can also be called a rhombi. So it has some rhombi on it. And those are parallelograms. Everything is parallel. And it has some squares. We know squares fit in all categories. So squares are also parallelograms. So I'm going to go ahead and add that to my list. The blue flag also has parallelograms on it. I might have more specific names for some of them, but they are all parallelograms. And here's the orange flag. The orange flag appears to have all rectangles and squares. So again, we know that those are special types of parallelograms. So I'm going to go ahead and add that one to my list too. The orange flag also appears to show parallelograms. The only one that does not is this green one because those are trapezoids. Okay, number 9 asks me to classify the quadrilaterals on the green and blue flags. Well, we just did that. Green flag. Those look like they are all trapezoids. Let me just check. This is my regular trapezoid that I'm used to seeing. This one looks like the same thing, just a little bit smaller. And this one is what we just did up here. That is called the right trapezoid. So it's got some right angles in it, but it's still a trapezoid because the top and the bottom are parallel lines and the two sides are not. Now they asked me to classify the quadrilaterals on the blue flag. So if I look at the blue flag, I have two squares. Oh, and I have two rhombuses or rhombi. So what can I call that in one word? Well, those rhombuses or rhombi that look like diamonds are not squares because they don't have the right angles. But I can also call a square a rhombus because what makes something a rhombus is the 4 equal sides, and a square is a special type of rhombus. It has the 4 equal sides. It also has right angles. So even though two of them, the best word for them is squares, they're all rhombuses or rhombi. So I'm going to go ahead and write that. The blue flag has rhombuses or rhombi, even though two of them are also squares. Okay. Number 10 asks me, Marcia says the red flag shows all rectangles. Bev says the orange flag does. Who is correct? Okay, looking for rectangles. So now I need to remember my definition of a rectangle is all right angles. So I want to check that now with the red and orange flag. The red flag right away I can see does not, because these shapes here do not have right angles. They have obtuse angles and acute angles. They do not have square corners at all. So I'm going to say no to the red one. Come over to the orange one. Well, these are clearly rectangles. They all have square corners, right angles. Oh, and these are squares. And we know that squares belong to all categories. They are a special type of rectangle. They also have all 4 right angles. So because it's all squares and rectangles, then yes, I can say that that is all rectangles. So according to that, I'm going to say Bev is correct. Okay. The red flag does not have all rectangles. It has all parallelograms, but only one rectangle. Okay, number 11 is our final question on this page and in this lesson. Should this quadrilateral be on any of the flags? So let me take a look at this quadrilateral. I have a right angle here, but not here. So don't be fooled. It looks a little bit like our right trapezoid, but it's not. Okay, this top is not parallel to this bottom. This bottom is straight across horizontal. This top is a little diagonal going up. It's slanty. Okay, so I certainly cannot put it here. on my square and rectangle flag because it does not have all right angles. It only has one. I certainly cannot put it here. This is my rhombus flag, and that has 4 equal sides, and these sides are clearly different sizes. Okay, I definitely cannot put it here. This is my parallelogram flag, and certainly these sides are not parallel. Okay. This is the only flag I really have to think about a little more carefully because it's a trapezoid flag. And this does, when I first look at it, look like it might be a kind of trapezoid. Now I have to look at it a little more carefully. Remember what makes a trapezoid a trapezoid. It has to have one pair of parallel sides. So usually it's the top and the bottom that are parallel, and the other sides are not. So now when I look at this shape more carefully, though, none of these sides are parallel. This side is straight across, and this one is slanted. So if I kept going, it might take a while, but eventually they would intersect. And this side is straight up and down. And this side is diagonal, so same thing. If I kept going, eventually they would intersect. So that means none of the sides are parallel. So it does not belong with the other trapezoids. So should this quadrilateral be on any of the flags, I'm going to have to say no. It does not fit into any of those categories. It is not a trapezoid, not a parallelogram, not a rhombus, not a rectangle. The only thing that I can really say about this shape is that it's a quadrilateral. It has 4 sides, but it doesn't have any of those other special traits or features that would give it a more specific name. So I wouldn't put it on any of the flags. Okay, so those are some ways you can construct arguments or check the reasoning of others when we're talking about geometric figures. You can draw pictures that either give an example or give a counterexample. You can look back at the definitions and compare the shapes you have to the different features. You can think through every part of what somebody is saying to make sure that all the parts are correct and think about whether or not that would always be correct or not. So there's some different ways that you can reason and construct arguments or check others' arguments about geometric shapes. Now we've gone over all the pages in the lesson of your book. All that's left for you to do today is go on to the practice buddy in your assignments, and I will see you in a couple days.